Hello and welcome to another engaging episode of Elektor Engineering Insights, where we meet the maker this time. I'm your host, Brian Tristan Williams, and today we're diving into the electrifying world of RF and high-frequency wizardry with a special guest from YouTube channel Baltic Lab, Sebastian.
Hey everyone.
How are you doing?
Pretty good. How are you?
Oh, that's great. I'm doing just great, thanks. It is a public holiday. I do have a slight cold, so if my voice sounds weird, just be thankful we're not in the same room.
Okay,
so as I told you before, I was in the 90s while I was wrestling with a colossal 4.8 meter satellite dish, attempting to master TV and satellite antennas. Sebastian was delving deep into the mysteries of waveguides, quarter wave dipoles, the magic of RF engineering, and his expertise extends beyond just knowing his way around a spark gap transmitter. If you've seen his YouTube channel, he's also adept with DSP and SPDR receivers and even the inner workings of a C-band LNB. Now, Sebastian first contributed to Elektor back in 2008, although I've said to him he doesn't look old enough to have done that. But anyway, he's since become a beacon of knowledge, illuminating the complex world of analog information transfer through his YouTube channel and blog posts in English and German. So he's a busy man, and today he's taken some time out to join us live to share his insights and take us through over a decade of his most creative and ingenious projects and experiments. Later, I'll let you know about our giveaway, which we do, and then we'll give you a code word later so you can join in. And but for now, let's start with Sebastian. You did it again.
You did.
Sebastian, let's start with C-band LNBs, because I know, although we have internet here in the big cities, it's really not necessary to even have a dish at all. We've got fiber, we've got high speed, but yet you'll find in Africa a lot of people are still using C-band. So you do see those big dishes around. I often wonder if they're still connected, or if they're just, they haven't bothered to take them down. But I believe some services are only available on C-band in Africa, although they would be digital now, not analog.
That's probably correct. Now, the immediate question I have from that, is the weather down there more humid and wet than it would be in Europe?
It depends. I mean, even South Africa, just this country alone has a wide range of different weather. You can get cold, rainy, and windy down in Cape Town sometimes, and very hot and humid in Durban, and it can be dry at times up here in Johannesburg. So it's a variety.
Because the background to that is really that the KU band is really subject to rain fade. So everywhere where it rains heavily or is very humid, you have a tendency of still having C-band dishes today. I think in India it's also the case, at least from the comments under my first video. And the overall history, I think, is C-band was the standard. And then when DirecTV started with encoder cards, they switched to KU band. The advantage obviously was smaller dishes because of smaller wavelength, but the disadvantage is rain fade. Everyone in Europe knows when it rains too heavily, your TV signal is gone. You don't have that effect as much with C-band because of something, I don't even know how to pronounce it in English. MIE scattering is what I would say, MIE. It's akin to Rayleigh scatterings, why we see the rainbow, but it's not as wavelength dependent. So the raindrops will actually scatter the KU band more than C-band. So for rainy areas, C-band is still preferable.
Well, that's interesting. I had this argument with someone in South Africa. We had KU band only come along in 1995, and I didn't think that it would happen because, I mean, it was a small market to address, and it was a footprint just over South Africa mainly, and I thought we wouldn't have the financial resources to justify that kind of investment. However, with digital TV, and I think we got the first digital system, suddenly where you had 4 transponders, you could now have 28 channels. So then it became more valuable and more versatile. So question I have for you is, with the rain fade that you mentioned, would it help also having a giant KU band dish? Because I had someone tell me dish size wouldn't matter, rain fade is rain fade.
Yes, and that's absolutely correct, because of course the antenna has a gain, but if you look at an antenna, the first thing people always ask, where's the gain? It's not an active device, so it can't really amplify anything. You're not going to have a power gain, and that's where the problem lies. If the rain scatters everything away, there's not much more for you to amplify. The gain is only a term used anyway in relation to a perfect spherical isotropic radiator. So no, a larger dish will not really help you at all.
Okay, so I lose that argument that I've been hanging on to for 20 years.
Oh no, if you would have mentioned that, I would have helped you out and would have reframed that differently.
Yeah,
And the problem is that, I mean, of course you can amplify the signal, but you're going to have a problem with signal to noise. You are amplifying, you're raising your noise, and you're also raising the signal. So no, a larger dish is not going to help you much in that instance.
Yeah, that's a good point. That's why we put our RF amplifiers at the antenna and not behind the TV set. Although you did get both variants, but if you have a long run of cable, you want the amplifier at the beginning, not at the end, because then you're just boosting the noise as well.
Yes, correct.
Have you been tinkering with C-band lately? I mean, that was your first video on your channel, so that was about, I don't know, 9 years ago. So when last did you touch C-band?
About 9 years ago. It was actually a transition in the United States where they threw all those C-band LNBs away. This is a special C-band LNB that had a waveguide mount in the front, and I haven't come across any since. So if you are in South Africa or anyone else that's watching and wants my address and send it to me, I'll do another modern teardown, but that has been 9 years ago.
Okay, let me bring your channel up just to have a look down here. I'll keep the sound off.
Hi, DIY guy Chris. Nice that you're here.
Let me show you how we do stuff around here.
Yes, and I said Chris because I spoke to him last, so apologies for that, Sebastian.
I know, I was
tools. No, that's not for me.
Well, Monday.com is all about flexibility, so you can make it your own. You could
And
choose
now I'm
pre-built
showing
layouts
someone's
for
ad
anything.
for free because I'm not signed in.
It's okay. I get money from it.
Okay. So again, DIY Chris, thanks again. Always cool to be here. Hi, guys. And it's always cool to have you here. It's great that guys from previous shows also join us here.
Yes, and it's always interesting to see what other makers are up to, because especially in the German sphere, everyone has their little niche. Everyone does things a lot different, and that makes it very interesting to seeing the live streams of other creators.
And what I would ask you about C-band, you said that it was available in Europe at some stage. Did some people have C-band dishes? I mean, they take up a lot of space.
Honestly, I've never seen it, but in the literature, allegedly, it started in C-band over here as well. But I couldn't say much to that because, as you pointed out, I'm a little bit too young for that.
Yes, indeed. Were you in America at one stage?
Yes, I was over there after high school, typical exchange student type thing. And in the United States, it's a whole lot easier to get stuff for free. If you want any crazy laboratory scientific equipment, there's always something. And if it's just for a few bucks on eBay, of course, it's a much larger country, so you get your hands on just about anything. And hey, Nicholas,
not only that, they were pretty early on the C-band thing. They were doing stuff. It wasn't intended for home use, but I mean, they were getting dishes back in like 1979 already, and things were unencrypted at that time. So they were making the TV broadcasters unhappy when they realized they could pick up things like HBO, and then people had to encrypt things.
Fun fact, in the United States, you can still capture the C-band feed. So the way that TV stations work, let's take an ABC7 station. You see that logo all over the place. There's different stations in the local markets. And all the stuff they play out, their main programming, is actually fed through to them through C-band satellite streams. And if you have a DVB-S receiver and a C-band dish, and you are in the United States, you can watch any show that airs during prime time a few hours earlier, because that's the point where they take down the ingress for their own servers.
Yeah, you get, I mean, to this day, you get, for example, Cartoon Network East and Cartoon Network West. And there would be a 3-hour delay between Eastern time and Pacific time. So I think that's the kind of thing that was peeing off the networks, if you'll excuse my French, because they wanted to control the market for this, and they never expected anyone to be putting these giant dishes in their homes.
I would actually pay to
Yeah.
get my hands on one, but not too much. You very seldomly see them. The best I have is an L-band dish for Meteosat satellites, which is just sitting in the room next to me, among many things. That's just unattended. I have so many ideas and projects, but so little time. I'm sure that's relatable. You know that issue. Oh,
Second video
Jesus.
from my
Yes.
video blog. As promised,
There's
we're
a
gonna
very
tear
young
down
Sebastian.
a C-band LNB.
I had more hair.
Actually,
Let's talk a little bit about the feedback
you
he
did
gave me.
indeed. That's
It's
why,
generally good feedback.
you still look a
and
bit
there was a little
young
bit on
to have
criticism
been watching for us
on
in
the audio
2008.
and the light.
But,
So the amplified
you
and
know, I've never
filtered
opened up
4
a C-band
gigahertz
LNB or
signal
any
goes
LNB for
into
that
this funny
sake.
thing. And what
But
that
I
is, I'll tell
remember
you in a second.
inside the LNB, the little pin that pointed straight up, even to this day in the KU band LNBs.
We can actually
Is
take a
the,
look at it in a second, because I have a
Yeah,
C-band, KU band LNB sitting under my microscope. But yeah, that's the black magic of microwave engineering. And what I'm uncapping right there is a dielectric resonator oscillator. It's a very interesting thing. I'm sure if you jump ahead like 20 seconds, we're going to see that pill. It's just a ceramic cylinder, which determines the resonant frequency of the entire thing. And that big metal screw that you see in the top right corner that I now moved out of the way is actually used for frequency adjustment. And yeah, right there under that purple-ish ring, that's just a spacer. That's just a tiny ceramic pill, and that's responsible for the entire frequency selection.
Okay, and you've got a KU band LNB to show us?
Yes, absolutely. Let me switch over to the end and start. No, actually, let's start from the beginning. So this is a standard off-the-shelf KU band LNB. It's a single one. There's plenty that have more than one output. This only has one. And if you take this apart, you're going to see the first interesting thing. This right here. And it looks similar on the beginning of a C-band LNB. This is what's called a corrugated horn antenna. So it's obviously a horn shape. That's where the name comes from. But these ridges right around here, they actually ensure a much broader bandwidth. Not only that, they also limit the side lobes, meaning the directivity is a whole lot larger. Now the size, I don't have a C-band LNB for comparison, but that is the entire LNB on the inside, and it gets even better. Now this is a modified one. That is the PCB. Just compare my finger to the entire PCB on the inside. That's all there is to it. I'm not sure if we're going to see that. Let me see if I can get a good angle. No, there's only the filter cap, but that's no problem. There is 2 monopoles in there, which are crossed 90 degrees. One is for horizontal polarization. The other one is for vertical. And that's all there is to it. Now I'm going to switch over to the Andon Star. Let me see. Settings, camera, USB video. There we go. Can you confirm that you can see that?
Yes, that looks great.
Awesome.
What are you using to switch the live video?
I'm actually just using StreamYard on the inside. I'm just clicking on settings and select the other camera source. Now this is the Andon Star 407 Pro, which I actually got from Elektor on a side note, going into an HDMI to USB converter, and it seems to work fine. And this is the entire PCB, and if I stick my finger in there, there's my fingernail. You just see the incredible size of the entire thing. Let's walk through this just for fun, because it's quick. Right there, and right there is where the horizontal and vertical polarization come in. I'm not sure which is which. There's one JFET amplifier, there's the other. They get combined, only one is active at a time. This IC controls everything. And then they go into another amplification stage. Now, a few interesting RF things that we see. You mentioned the hairpin filters. Up here is one. This is just a simple coupled line filter, which will probably have a center around 11 gigahertz. We could measure, but we're not going to do that. But these little things right here, which looks like a circle, or a section of a circle, have you ever seen those before?
Not really. I can't say I have. I've never toned down one of these.
So what they are is they are so-called radial stubs. I'm sure here and there everyone has heard of quarter wave stubs, but many haven't understood those, which is perfectly fine. Basically, this open stub has a wavelength of about a quarter of a wavelength at the center of where it's supposed to attenuate. And at that frequency, they present a dead short. Now, if that would just be a little wire piece, then that would be just at a very sharp defined frequency. By making it radially shaped like this, it actually has a broader bandwidth. So the purpose is, here's a bias voltage going to the gate of the MOSFET. And obviously, we don't want any RF leaking through the DC path. So this is going to be about a quarter wavelength long, and this is, so here, all RF that wants to go this way is shortened, but this way we have a quarter wave short and another quarter wave, which will transform to an open. So from an RF standpoint, this is an open, so it can pass without being impeded. And that's extremely interesting. This is some of the RF magic that's really fun to play with. Now this IC does a couple of things. First off, down here, that's where a crystal is connected, a 25 megahertz crystal, which is the reference clock source. It gets multiplied by 390 or 420, depending if you're in high band or low band, mixes the incoming signal, which is going to be around 11 gigahertz, and then sends it this way. This is the F connector on the background, on the back of the LNB, which I disconnected. And right here is just a common 7806 voltage regulator, just like we would use in our personal projects. And this is a little PCB inductor just to keep the RF out of this path. And that's really all there is to this KU band LNB.
Well, that is quite interesting. It's so small these days. Do you think there has been... I think I'm picking up an echo from your end, Chris.
Sebastian, still. Let me try to turn down.
Chris is here again, so I keep mentioning him. He's saying, interesting topic. I was advised to use a C-band receiver years ago because I live in a very foggy city.
Yes.
Are you talking about a dish, Chris, or a receiver?
I think he is referring to that, what I mentioned earlier. I don't know if Chris was there yet at that point in time, but yeah, humid and rainy areas is where you would... Chris, where do you live? You are, isn't he German? I don't recall. I mean, I watched the live stream, but maybe post in the comments.
Yeah, but I believe he's in Tunisia.
Oh, yeah, right. So there they actually also use a lot of C-band because of humidity. So that would be absolutely correct.
And then I would ask you, do you think, because the last C-band LNB I owned was probably from around 94 when it was made, and how much analog electronic improvements has there been to, say, the signal-to-noise ratio of an LNB from 30 years ago versus one from now?
If you believe the manufacturers a lot, like LNBs like this, they state a noise figure of 0.1 dB. This is plain marketing BS. That's not true. In reality, whenever you cascade a bunch of amplifiers, especially in that frequency range, it's really just the first amplification stage that determines, well, the other ones do as well, but it's the primary source of noise for the entire chain. The thing behind it is called the Friese equation. At least that's what it would be pronounced in Germany. I honestly do not think that there is all too much of a significant difference. I think they're going to be fairly similar. Now, back in the day with analog television, they weren't good in regards of frequency stability. They weren't good in regards of phase noise. None of that mattered because the analog signal was like, what was it, 6.5 megahertz wide. So they didn't really need to care much about that.
I think it depends on the system. I think PAL was 8 megahertz, including the audio. But yeah, the video was probably down to 6 megahertz.
Yeah, you're right. I think it was something like that. In amateur radio, they use a reduced audio carrier of, I think, around 5.5 megahertz. Then in television, I think it was 6.5. And now if we do 2 times max deviation plus 2 times max frequency, then we would get the bandwidth, which is quite a bit. So yeah, there it didn't matter. Now with QPSK and even higher multi-array PSK methods, you need to be a whole lot more precise, especially for the symbol timing.
Yeah, and if I remember correctly, the transponder width on a satellite, at least from C-band, was 27 megahertz.
I do not know that, honestly. I would have to look it up.
Yes, finally something you don't know.
I would suspect that depends on the satellite provider. I'm trying to remember what it is in KU band. I don't know. All I know, although I should probably not say that on a live stream, why not? If you take the uplink, the transponder really just is a linear transponder. It picks up what it receives and sends it right back down on a translated frequency. So if you were to get your hand on a KA band, or is it K band? It would be KA band, a KA band block up converter, which you can buy on eBay. You can actually start broadcasting through a TV satellite. Now, I wouldn't say that. Yes, you can, but you won't be able to do it for very long because, of course, the operators of the satellites have methods of notching you out very quickly. But for a brief moment, you would be able to do that.
Okay. Moving on now to the giveaway. I just want to let our audience know what we have to give away, and that's what you're seeing on screen. It's a great little kit for playing with software-defined radio, which if you look at Sebastian's channel, he has done quite a bit of that, even using, you used SDR to pick up sounds from clinking your keys because you couldn't find any other source of ultrasonic audio. Anyway,
that is
we
correct.
will tell you how to enter the competition later in the show, and we'll give you a code word for that. But just stand by because you can win this. Tell us about picking up ultrasonic audio using software-defined radio. I mean, ultrasonic and radio are two different things.
Yeah, very quickly, let me just address DIY guy Chris here. He says first North Tunisia, very pretty there, by the way, but also very humid. I've been there on station before. They're human as well. I really liked it down there. And no, well, yes, KU band downlink, but KA band uplink. So the uplinks are around, I don't know, 14.5 gigahertz, and the downlink is centered around somewhere 11 gigahertz. Now, towards your question, very interesting. Like the background story of it is, let me actually grab it from the shelf, and audio should stay fine. That's why I got the wireless clip-on mic. Here we go.
I hope your battery is charged on your wireless clip-on.
This one right here. Now, this is a really upper class. Yeah, I'm going to call it upper class STR receiver. It has 3 inputs. One of them can actually supply a bias voltage for an antenna, and there's a reference input. And the background story is I got that one from Clemens from Elektor for a review. He asked me, do you want to write a review? I said, sure, why not? Now, the problem is every time you say, yes, sure, I'm going to do something with it, you have to actually deliver and you have to come up with ideas. I was thinking, well, this thing starts at about 1 kilohertz, which is, or was it 9? Well, anyway, very, very low. So I was thinking, what can you do in that range? Well, one thing you could do is look at VLF stations and try to listen to thunderstorms, which is, by the way, very interesting. There's these things called spherics, which go along the magnetic axis of the Earth and just bounces back and forth. But there were no thunderstorms. So what are you going to do? And I thought, well, this is right in the audio range, but doing something directly in the audio range is boring. And I had these little MEMS microphones. So yeah, there's the video, exactly. I had those MEMS microphones laying around, and I thought, well, let's build an ultrasonic receiver. And then the problem, yeah, there it is, exactly, the tiny itty-bitty MEMS microphone. And so I still needed a source, and I couldn't find anything. I couldn't think of anything. And then I actually tossed my key when I came back on the workbench and looked at the screen, and there it was. There was the ultrasonic sound. Now, obviously, if you research it, also water and gas leakage, well, yeah, if you know what you're looking for, you're going to find something. If you go forward, I think there's the water. Yeah, it's another channel that did something that I featured in there. And there you can see pouring water is also going to emit quite a bit of ultrasound.
Wonder if we can do audio.
Some coupling and decoupling capacitors according to the datasheet recommendations. Because of the extremely small LGA5 footprint of the microphone, I didn't even want to bother of trying to etch this at home. So action of my Siglant SDS2104X HD and an external.
So you got ultrasound from pouring water, and you thought of keys after that.
Yes. And I built a little amplifier, that's what's shown right there, that prefers the problem is this thing, of course, has a 50 ohm input impedance. And so you can't hook up a microphone directly to it. So I built a little amplifier that
Most reliable ultrasound source has.
I mean,
So
if you
you
just
don't
play
have-
the video at the right location, I can just, me from the past can just tell that.
Okay.
Yes, and there's SDR Uno.
Well, it's a pity you didn't have any bats there. Oh, that's
Another
fascinating.
also is quite audible in the ultrasonic range.
Well, I bet you're surprised Clemens with that use case for this kit. We were expecting these to do something in the radio frequency.
Yes, absolutely. And that's actually on the list of, I don't remember, Jens already got back to me. Did they, I don't know, I'm not going to go ahead of anything, but I've submitted that idea for Elektor. But the next article of mine that's going to appear is, I think Jens said, in the September issue. The C-band LNB, no, KU-band LNB, see now I'm all together with the bands. There's a way of modifying it so that you can listen to 10 gigahertz signals from radio astronomy or radio amateurs. And that's going to be, I think, in the September Elektor issue. So just a little teaser right there.
Great. I hope the audience is paying attention. Get that edition of Elektor. I want to move on to what you've done with the Arduino Giga.
Oh,
which I
nice,
believe
yes.
was also an Elektor request. And that's you playing the guitar, right?
Correct.
I'm a keyboard guy myself, as you see behind
The
me. I've got a
distortion
guitar.
effect you just heard was completely.
I have a guitar, but I never pick it up, so nowhere near as good as you. Now, this Arduino Giga, it has two 12-bit analog to digital converters, right?
DACs, two 12-bit digital to analog converters. Yes, and it also has I think it's even 14-bit ADC with several channels. So I thought the obvious thing, Arduino's, the original Uno R1, they have always been lacking in digital signal processing. So I thought, perfect. Elektor got me a, what was it, Giga R1. So I have to do something with it. And that was the first video. And the thing is, that beast is so powerful that you can actually calculate everything at runtime. You normally wouldn't do that. If you do digital signal processing, you would have tables with your sign lookups, like that transfer function that's shown right there for 4096 points, possible sampling points. You would just put that in a table and look it up. But the Giga is so powerful that you can even do this exponential function at runtime, and that was really fun to play with.
Well, it looks like you had fun to play with that. And it just reminds me of something. When I had digital television on KU band, my first receiver was a Samsung, which was quite nice because it had RGB outputs. So it didn't even, you didn't have to get composite video. But what was interesting is I managed to get a workshop manual from Samsung in Europe. They were very kind enough to send me one in the post when I said that my receiver had broken down, which it had. And very interestingly, straight from the LNB, the first thing that they did with the signal, the analog signal, that high frequency, I don't know, I guess it's down converted to about 950 megahertz, if I'm not mistaken. That's still quite a high frequency. And the first thing they did was convert it to an 8-bit digital signal so that they could work on it, on the quantization and stuff. That was crazy at such a high frequency for me. Now, what sort of frequency were you working on the ADC there on the Arduino Giga R1?
I think I cracked the sampling rate up to about 200 kilo samples per second, and the maximum reasonable input frequency to expect would be in the audio range. Now, there's a big catch to that. If you sample, let's say 48 kilo samples per second, which a normal sound card has, a better has 96 kilo samples per second. The maximum frequency that can be contained in that is, we all know the Nyquist-Shannon theorem, which basically says half the sample rate. Though this is not entirely correct, and I'll circle back to what you said about the 950 megahertz. if you do distortion, like I did in that video, you are going to generate harmonics. And if you add a lower sample rate, the samples are at that lower sample rate. And now you introduce distortion that might lay outside of the Nyquist one zone, first Nyquist zone that way. And you will create aliasing that you do not want. So here I bypass this. I think if you go to the first line of the code, you can't, it's in the video. Let's see, can you scroll back just a little bit? Pretty sure it was 200 kilosamples per second or so. No, I was actually at 48 kilosamples per second.
That's interesting.
Well, maybe I lied there. Okay, let's reframe that. If you do this, you should use a higher sample rate because you will create aliasing. Back to your thing with the 950 megahertz. What they often do, and here's where many people get Nyquist wrong, and actually there's an article in Elektor that wrote on that. I think it was called sub-Nyquist sampling or something like that. The deal is the bandwidth of the signal needs to be smaller than the half the sample frequency. You can directly sample a 950 megahertz signal with a 30 megahertz ADC if it has enough analog input bandwidth, and this is probably what they have done. This is called sub-Nyquist sampling or subsampling, as long as the bandwidth of the sample signal is smaller. People always say, well, the alias is wrong and there's mixed frequencies. No, there's not. Within that Nyquist zone, there's only one discrete solution to those samples. There's no exceptions to that. And it confuses people a lot, and that's why I wrote that article. Yeah, sub-Nyquist sampling in practice. I think it's even a free download. I'm not sure, but or maybe Elektor.
You have to be a registered user to download that.
Okay, well, but that's no real threshold. So go sign up if you haven't. And it's really interesting because there I'm using an Arduino Uno, a old Uno that is very slow in sampling, but I'm sampling a 200 kilohertz signal directly. And there it's actually important to know the exact frequency because that was part of a metal detector. And many people don't think that's possible, including the professor that was actually supervising that project. So they were all very stunned that that's possible. But yeah, it's called sub-Nyquist sampling.
Yeah, and we had this discussion before when I mentioned that CDs, for example, had a sampling rate of 44,100 hertz or 44.1 kilohertz. Presumably, I assume to capture audio up to 22 kilohertz, which wouldn't be great up there because you'd basically be getting square waves at those frequencies. Hence, 48 kilohertz, 96 kilohertz, and yeah, you used 48 kilohertz in that project. How would the sub-Nyquist sampling apply to, say, CDs? What is misconception we've been having?
About CDs, I wouldn't know any relevant thing where this really matters, because you would never come in a situation where you would intentionally sample something higher. The audio range is up to 20 kilohertz, and I think 44.1 kilosamples per second is just a bit higher than half, because here's the deal. You never want to be right up at half, because if you're there, you have two samples for that signal with that frequency component. Now, what they always show you in university in presentations is if you have the sine wave and you sample the peak and the low point, then yeah, you can recreate the sine wave. But the worst thing that can happen to you is that you're gonna have the zero crossings because there's no synchronization, right? So you always want to have a little bit more. Now, why exactly 44.1 kilo samples? I do not know. It probably was relatable to some standard clock frequency. Then you saw 48. Now, was it 96? Yeah, and then 192, yeah. I think is what's very common these days.
And what about the bit depth? I mean, CD is 16 bits per channel. Does it really make a difference if you go up to 24 or 32?
Well, does it really make a difference? Yes, you get more dynamic range. Does it really make a difference for modern music? Probably not, because they're highly compressed anyway. That's the sad truth. And maybe if you haven't seen it, to all the viewers, there's what was it called, Loudness Wars. It's very interesting how heavily compressed audio is these days, and that's why you have so much more fidelity and dynamic range at a concert as opposed to broadcast and CDs. So I would claim no, these days it does not make much of a difference.
Okay. I want to switch now to some comments here. Jesus is watching from Brazil. So greetings to the Western Hemisphere there. That also reminds me of the satellite days. I'm about 28 degrees east of Greenwich, but obviously Brazil and America are west of that. And the first satellite that my big dish was connected to was 27.5 degrees west. I believe it was Intelsat 601. And yes, used to get signals bounced from the US and then to a receiving station in London over the Atlantic Ocean and to my dish. You know, it felt a lot more special than when you picked up something from far away. I had a cheap satellite receiver with a dial to tune. When you picked up something from overseas, it was magical. And then we got these digital TV providers providing from local. I mean, they pick them up locally with their big dishes, then they put it to K-band. It's not as special anymore. It's all packaged for you, and you pay for it. But I see there are still ham radio guys doing that, even though, you know, we got internet, we don't need it. It's still fascinating to them. Do you dabble much in ham radio? Because I heard you give your call sign away.
No, not in Germany, because no, I would have almost said something that would have gotten me canceled. The thing is, in the United States, like I said, and you have to be careful. You said even though we don't need it because there's internet now, you can't say that in front of amateur radio operators. Do not, under any circumstances. Brian didn't mean it that way. No. In Germany, there's not that much in the niches that I'm interested in. Yes, maybe it's also because I'm living in northern Germany, which might be a problem in that regards. So the gigahertz ranges are pretty silent up here. In the United States, this was different. You would always have somebody in driving distance or radio range that you could do experiments on 10 gigahertz, 24 gigahertz, or even 47 gigahertz. That was fun. So in Germany, absolutely not. And the argument always is that, yes, we do have the internet, but how reliable is it? This is emergency communication, but I think this is just a public justification for it, because in all honesty, why do we do it? Because it's fun. It's just like, why do you ride your bike to work when you have a car? I mean, you could say we don't no longer need bikes. Well, okay, you could now make an argument for sustainability, but you know, it's fun. Building your own transceivers, your first receiver to receive shortwave signals has been sent around the entire globe, and then actually building the transmitter part to just with a few transistors send a signal around the entire globe. This is of course very empowering and exciting for hobbyists in particular, and I think this is really the interesting part about it. And the good thing about it is, automatically when you reach somebody on the radio, you have somebody that's interested in the same thing. Like if you and I would go to Maker Faire, we would meet many people that have the same common interest, but maybe not in our niche. You know, you have to kind of check out what are they interested in, whatnot. But on amateur radio, everyone's naturally interested in radio. So the social aspect is probably also very important.
Yeah, and no, I wasn't saying to amateur radio guys don't get into that, but you know, it still fascinates me. It gives me very warm and fuzzy feelings when I see fuzzy video that I recorded from 30 years ago, because it was such a magical thing to be able to pick up a signal from so far away. I tried shortwave radio. I wasn't very successful at that. I could never get the antenna right, or maybe it wasn't big enough, but just picking up something from the other side of the world on your own without it being packaged to you by a local cable provider or something, that was magical. And yes, the emergency broadcast scenario is very important, I guess, but those emergencies hardly ever come up. But I have seen in the news, like in the States, where they've had hurricanes and that sort of thing, where everything was taken out and the amateur radio guys were able to step up and, you know, save the day. So kudos to them.
And there's still a lot happening. Yeah, there's still happening on shortwave these days. You would think that with everything around the world being more digitized, that shortwave is pretty much dead. And it's not just amateur radio. The aircraft, when they're over the Atlantic, Pacific Ocean, they are in contact with Gander or Shenwick radio. You could still listen to it, with that SDR receiver, for instance, though you should check your local laws first. And even with the current situation in the world, for instance, on 8.992 megahertz, you might be able to listen to the US Air Force high-frequency global communication system. All this stuff is still out there. They still rely on shortwave as the backbone to everything. And yeah, I think you wanted to lead over to the giveaway.
Yes, I do want to say something about shortwave because you remind me of something, but let's attend to our audience here who's waiting patiently. We said we were going to give this away, so I want to tell you now how to enter this. So it's the Raspberry Pi 5 RTL SDR V4 bundle. It comes with a whole bunch of things. As you saw in the previous picture, you've got your book, you've got your Raspberry Pi, you've got the SDR. So it's all here. Head over to that URL that you see at the top. It's been dropped in the chat, but I'll put it up here as a banner. electormagazine.com/elector-engineering-insights-giveaway. And in order to enter, you have to fill in the code word there. And here it comes. Because Sebastian does content in both German and English, I will say that the code word is German, it's Labor, but in English, it's labor. So either way, you will.
They're closely related to each other.
Tell us more about that. I mean, I'm a language fundy. How is laboratory in German, Labor, related to labor?
Well, that was just my tongue-in-cheek for, well, you do perform labor in the lab. I'm actually somewhat certain that's actually where the German word's origin is from. But yes, labor that way means nothing else but laboratorium at the same time. This is where you do work. No, I actually got to look it up in the background. They are related to each other.
Well, of course, in the UK and South Africa, the spelling is L-A-B-O-U-R, but don't get confused. The code word is L-A-B-O-R.
I got to hop over to that giveaway now, see if I can win as well.
Well, you better use a fake name, otherwise we are unlikely to award it to you when you come up.
Well, I wouldn't do that to the viewers, so... That little SDR that's in that kit, is, especially with the Raspberry Pi 5, is a very powerful combination. You can, for instance, build your own radar for flights. You can take the ADS-B signals and feed them either into flight radar or similar services, or just have your own local radar. Also, if you're close to the shoreline, like me, you can, in parallel, actually, at the same time, receive AIS signals of ships, which is always very interesting to have your own view. You can also operate that thing remote, so you can put the right image on the Raspberry Pi, put the SDR in, put the antenna somewhere where it's safe, and then just when you're on the go, you can log into it. You of course need port forwarding, and then you'll have your own broadband receiver sitting at home, and you're going to be able to listen to anything you like to.
Well, that looks interesting. Like I said, I'm more digital nowadays, working with Arduinos and Raspberry Pis and all that sort of thing, but you're wetting my tongue here. My appetite for back in the day when I did do analog TV and shortwave radio, I think I should try one of these. Let's have a look at some questions and comments. Udo, tuning in a bit late, but great to see some live insights about the project. Cheers. Cheers to you, Udo. Let's have a look at Magic T. More common 90s TV set uplink delays in KU band around 14.5 gigahertz. There are many powerful klystrons from transmitters on eBay. KA band is a more modern one. Yeah, I believe KA band's higher, is it?
Yeah, he's absolutely correct with that. I realized my mistake earlier, but if I'd start correcting every mistake, then we would need another hour overtime. That's how it is when you're live. But yeah, Magic T, you're absolutely correct with that.
Yeah, I still make mistakes on edited videos, so don't worry about that.
Same
and
here.
Pratt H says, cool workbench. Perhaps we should hire some fact checkers to fact check us live.
That would probably work too, but I've stopped editing errors out. They're just part of the game, and in all honesty, the more mistakes you have in, and I wouldn't suggest anyone doing mistakes intentionally, but I have one, it's a TikTok reel actually, that there's one mistake in there, and I have several hundred comments because of that mistake. Well, the social media platforms consider that engagement, so that's fine.
Yeah, I also accidentally got some of that engagement when I called an RJ45 connector and RJ11, thinking of the telephone plugs. But hey, it got engagement, as you say. I just wanted to go back to shortwave because you reminded me of something. When the space shuttle was going around Earth, again back in the 90s, I was able to receive NASA TV live 24/7 on C-band. And what was interesting to me was that you could get these full, SD at the time, but full PAL TV picture in full color of what was going on in the shuttle, but the sound was always. And then I found out it's because you'll notice that the video drops out sometimes when the shuttle goes around the other side of the Earth, but using shortwave, they're always able to have an audio connection to the shuttle.
I wish I would be a little bit older so that I would have had the chance to listening to all that stuff back in the day. That must have been so interesting. I also do not know if you've ever seen like the radio amateurs when the Apollo stuff was going on with the first moon landing and all of that. They were actually sitting on the ground with S-band dishes and were listening directly to the signals coming from the moon, even from the what's it called, lunar orbiter. They were picking that up on the ground. Now, to be fair, back in the days, this needed specialized equipment, and most of those people that did that were professionally working with it. But that's just so cool what you were able to listen to, and nowadays there's not that much, unfortunately. It's still interesting stuff, but not as much as there was back in the day.
Yeah, well, maybe I'll share some content with you sometime, because in the closet behind me is hundreds of hours of VHS tape that I recorded, including from NASA TV at the time. And also I was in a thrift store and I found an audio tape reel, one of those old audio tapes, reel to reel. I haven't played it, but it's labeled Moon Landing 1969. So I don't know what's on it, but it should be interesting when I finally get to play it.
You should digitize it and upload it.
Yeah, well, that's my plan, but there is so much content, which is why I'm working a bit with AI now to try and help me to curate the stuff, because I will not have the time to go through hundreds of hours manually and take notes, and I need voice transcripts and object detection, that sort of thing. But that's taking us a little bit off topic. I want to go back now to another project, which was tremolo on the Arduino Giga R1. Now you're sounding like a pro.
What you just heard was a
So you did tremolo and you did distortion. Any vibrato?
No, that was it for now. But here's the thing. Like, I thought this project was very interesting, but I really do not have the time to dig deeper into it. I wanted to do so much more with, what is it called? Well, cap modeling, so modeling known amplifiers and similar things, but time is running away. Now, starting in June or end of June, I'm going to have a whole lot more time, so I'll recheck that. See, it always depends on what my viewers want, right? So if they write under the videos, I want to see this next and that next, I will surely do that. But at the moment, that was about it for DSP effects on the Arduino Giga.
Yeah, again, giving away my age, but in the late 80s, I had a Casio, I think MT70 keyboard, and it's become a classic now. I'm sorry I got rid of it, but it had lovely vibrato and tremolo and effects like that. As for distortion, you still get distortion pedals, but I remember those back then. And I was, back then I was fascinated with speech synthesis. Just getting a computer to do anything with a voice was amazing to me. I even laid out for a speech synthesizer on my first computer. And what I always wanted to try was what would happen if I would plug a microphone into the distortion pedal instead of a guitar. Have you ever tried anything like that?
Not at all, no. And what was the result of that?
Well, I haven't tried it. That's why.
Oh, I thought you did. I think I've seen it somewhere, but I have never done it myself. Now, I can't do any instruments with keys. It's just not for me. So, but I think I've seen that before, that somebody uses guitar pedals for keyboards. I mean, why not? It's audio, right? But here, now you have all the tools. I'm sure you have an Arduino laying around somewhere. You have a code sample, so you could try that.
Well, I don't have a Giga R1. I've got much slower Arduinos, unfortunately. I'll either have to get a Giga R1, which is quite pricey for one experiment, or perhaps you could eventually tell us how to do that on a Raspberry Pi.
Well, that's the unfortunate thing. When the Raspberry, no, not the Raspberry, when the Arduino Giga R1 came out, I thought, well, finally an Arduino that's fast enough and has the equipment to do that. And then shortly after that, the R3 was released. Now, the R3 only has one DAC, but that's more than sufficient for effect panels. If I would have known that, then I would have probably used that. But also, thanks to Elektor, I have another R3 sitting on the shelf, and that's actually one thing that's on my list, because many people objected the Giga is too expensive for those experiments, and they are right. So if I can get that started on the R3, I think this is much more reasonable. I forgot what the price of the R3 is, but it's not much, so that would be justifiable.
Well, it will certainly be interesting, if not justifiable. It might be expensive. Let's go over to this other experiment, which is fascinating. The way you changed an LED color using liquid nitrogen. Tell us about that.
Oh yeah, that was interesting. I don't even know how I came about that idea. But many people... Yeah, I do know. I was lecturing a few students on semiconductors and their behavior would change in temperature, which is complicated, especially if there's first semester students. But so I thought, what can I do so that they'll see it? The first thing was, okay, let's make sure a diode burns down due to thermal runaway. And I thought, no, that's kind of boring. Let's show something different. And in short, the color of an LED depends on the size of the band gap, which is really just the difference in two energy levels. For electrons to move out of the nucleus, and I'm not a chemist, Niklas, who's in the chat, is, so correct me if I'm wrong, but to get in the valence...
You have enough chemical equations there.
Yes, but there's still more physics, so that's cool, but I'm not a chemist. So, and this energy difference depends on temperature and is directly related to the photon energy. So I thought if I take an LED and freeze it really, really low, then this temperature dependence will be clearly visible, and it is. This works with every color LED, but since green is so distinct for the human eye and is very close to the yellow range, this was really the best result. I think in that video I also showed different colors, but it's not as pronounced. And seeing this in real life is a whole lot cooler, because as you can imagine, we talked about sampling earlier and dynamic range. This is analog color. This shifts continuously from yellow to green or from green to yellow, and there's no discrete steps. It's just, you've never seen that many colors in your life within a few seconds.
I know. I wonder if there's a practical application for that. Can you imagine televisions shifting LED colors with liquid nitrogen floating through? I suppose not, but you know,
that would be a TV I would buy.
Exactly what you do.
A cryo-cooling TV would be absolutely what I would buy. I'd be all for that.
Let's have a look at some comments here. Advanced Tinkering says hi together. And I see you're also having time to say hello, Sebastian.
Yes.
We've got hello from Germany, near Münster. We're running about 6 minutes on time, and I just want to know if you guys have any more chats in the chat room. Please drop them now so we can get to your questions. But for now, Pratt H says, cool workbench. And I agree. How long did it take you to build that up? I saw in your first video on your channel, which wasn't the first video at the time, but now is the oldest video on your channel. You mentioned that you got some criticism for lighting, and you got 3-point lighting. I'm still using 2-point. I haven't gotten around to putting the one up behind me. So you've got a lab, and you've got a little studio, and I presume an office. How long did it take you to get all that together?
Years. In Germany, at least 5 years. It takes forever, and I'm still not happy with everything. The lighting right now, not lightning. Lightning is something different. There's a light right there. There's a light there, and you also wear glasses, so you always know the problem with glare. It seems to be okay. I have an orange light over here, which doesn't show well because the sun's burning through the window, and over there is a blue light, which was visible a whole lot better earlier. They are battery-operated lights, which are good for filming. They're very reliable. And the biggest issue is always sorting stuff. And just putting the big stuff, the oscilloscope and the lights, that's no big issue. But sorting all the components away, and then especially when you do surface mount, then you need your 0402, your 0805s and everything. Word Electronic actually solved some of those issues. Let me show you. Like for capacitors, inductors, and all of that stuff, I have these really cool boxes. Let me see if I can get them on there without glare. The camera is not going to do it much better. But they're available from the Word ISOs group, which, people always think when they hear Word, they think of screws and stuff like that. But they do these component sets, and they saved my life in regards of getting room, because you can just stack them away and you're done with it.
Yeah, I bought some resistor kits recently. That's very, very different from back in the day, first times as a teenager when I used to go to electronics store, having to go through their drawers one at a time and take out 10 resistors, and they were like 2 cents each. So they wouldn't even count them. They would just trust what you said, but you would try and fill your component drawers with all the different values, and now you can just buy them in one kit.
Yes, and nowadays the prices have dropped so much. Like recently I threw out, I gave them away, all my 5% resistors. Why not use 1% or even 0.1%? It makes no difference in regards of price. And that's actually one thing I did in general. Everything that's of lesser quality I tossed out, and by tossed out I mean giving it away to students or similar that can direly need them. But yeah, nowadays it's a completely different world with components, plural.
Yeah, well, absolutely. I mean, for my own projects, I would always try and use a 1% resistor, even if more expensive, because I wasn't doing a production run. I just wanted to make sure my project worked and worked well. I suppose when you start doing things at scale, you have to consider cost effectiveness. But now, as you say, not much difference.
Right.
Thanks to Asma for sharing a question from Instagram for us from Otronic Electronica. Have you seen what Marcel License does with Arduinos and ESP32 synths? It is amazing.
I have not. Have you?
No, I haven't. But I can say that in a couple of months on Meet the Maker, we will be having a famous YouTuber, Look Mum No Computer, and he does a lot of analog synths and all sorts of circuit hacking and that. So that is something to look forward to. I see we've got 1.5 minutes left, so I'll take this opportunity to thank you so much for joining us, Sebastian.
Anytime.
And I'll also thank Chris for joining us in the chat, even though you are not Chris.
Yeah, for all the viewers, Brian had that mixed up in the beginning and called me Chris a few times, which is fine. Like, give me whatever name you want to. And I also would like to give a shout out to another one. There was Nicholas from Advanced Tinkering. We had him earlier in the comment section. If you're interested in more of the chemical type things and sputtering and stuff like that, that's the channel for you to check out. It's also very interesting. He always stresses he is not an electrical guy, but there's still electrical stuff on there. It's very interesting to watch.
Nicholas, yeah. I'll make a note of that. I want to check that out, because you've done some other things which aren't electronic related, but the kids enjoyed watching them with me. For example, your glowing slime. That was an interesting one. I'm going to check out Nicholas next, but I would advise everyone who hasn't already to check out Sebastian's channel, Baltic Lab. And of course, as we come to the end of this, and I thank Sebastian, don't forget our channel for our forthcoming shows. You can, let's put it up on screen. Just look for Elektor TV on YouTube, where you can find the upcoming shows. We will have one at the end of next month and one at the end of the month afterwards. So we hope you join us. And I thank you all in the chat for joining us and the great questions. And it was awesome to, I don't want to use a four-letter word, but to shoot the S with you, Sebastian. It was great talking about shortwave and analog and reminding me of the old times that I used to enjoy so much of that. Thanks so much for joining us.
Anytime. Sure was fun.